Okay, this video is going to continue the notes for Chapter 6, Section 3, Vectors. We're going to say this is Part 2. We're going to pick up sort of where we left off yesterday. So if you were in I period yesterday, we're going to start a little bit earlier. If you were in A and C period yesterday, we got a little bit further.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So we talked about vectors. We talked about PQ representing a vector and the difference between the initial point and the terminal point, arrow always pointing towards that terminal point. We found the component form of the vector to be x2 minus x1 and y2 minus y1. And then we talked about magnitude. If from the initial point and the terminal point, you can use the distance formula. Or from the component form, you can find it by the square root of a squared plus b squared. And we worked through equivalent vectors, this example, and we left off after here. Scalar being the number that would be multiplied to either stretch my vector or shrink it. If I started with just v and then it said 2v, this should be twice as long. A half v should be half as long. And if it has the negative, it's going to change the direction of that arrow, which was in all of these pointing up. Now it points down, and it's 1.5 times the length. We talked about all the things you can do with vectors, adding, subtracting, and then multiplying by a scalar. And drawing the sketch of the vectors. So just a quick refresher on that. If I had something like -2, 3, and I wanted to sketch this, because I know this is already in component form, this is not a coordinate point, but I would start at 0, 0, and then I would go change in x, so left 2, change in y up 1, 2, 3, and plot a point, and then the vector is connected and arrow pointing towards that terminal point. Then example 2 is where some of you got all the way through and some of us didn't. So we're going to quick review that. A is u plus v. So for that one, I'm going to add the first two terms in each, 2 plus 1, and then add the second two terms in each, 1 plus 3, and I'd get 3, 4. And then when I draw the resultant vector, or sketch it like it says, I'm going to start at 0, 0. I'm going to go right 1, 2, 3, up 1, 2, 3, 4. Connect those points, draw the arrow towards the terminal. Then comes B, which is u minus v. This time I'm going to do first minus first, so 2 minus 1, and then 1 minus 3. And I get 1, negative 2. This time, start at 0, 0 again. Go right 1, down 2, and that would be that vector. And then C is 2u minus 3v. So we've got a scalar and the difference. I'm going to take the 2 and multiply it in on u. Subtract from it 3 times v. Distribute this to both. I get 4, 2. Minus, I'm going to distribute then positive 3, so it's 3, 9. If I had distributed a negative 3, it would have been 4, 2, and then it would plus negative 3, negative 9. So you can choose either way, it's the same answer. And then I'm going to do first minus first, so I get 4 minus 3 and 2 minus 9, or 1, negative 7. If I had done it this way, over here, it would have been 4 plus a negative 3 and 2 plus a negative 9. I still would have gotten 1, negative 7. When I draw that vector, I'd start at 0, 0. I go to the right 1 and down 7. 1, 2, 3, 4, 5, 6, 7. Connect those points. and do the arrow. Okay, the other way you're going to see the sketching happen is in homework. You'll sometimes see, let's say it gives you a vector. It'll say, this is vector u. Draw 2u, for example. So if this is u and it wants 2u, then it's double the length of that vector. If it said 1/2 u, it would be 1/2 the length of u, so maybe around there. If you're going to add two vectors, so let's say it says this is u, and this is v, and it wants you to add these two vectors, then what you're going to do is draw almost like a parallelogram. I'm going to extend this side here, but make it parallel to that other side, to the side u. And then I'm going to extend this side, making it parallel to v. And then where the two cross would be the terminal point of the sum of those two vectors. If you started with that same initial question, so let's go back a little bit, erase this. And it said to find 2v plus u, then the first thing we're going to do is take v and double its length. Again, we're going to kind of eyeball this. And then extend out that side parallel to the u, extend out this side parallel to the v, and now where those meet would be 2v plus u. So the good news is it's multiple choice. On your homework it should be a little bit easier, but make sure that you would know how to draw those when it comes to test time, which was not multiple choice. Okay, everything we just learned in component form can also be written in something called IJ format. In IJ, the horizontal distance, which is usually the first number, like U1, would go in front of the I, and then the second number, or the vertical distance, would go in front of J. So if I had 2, 3, it's the same thing as saying 2i plus 3j. If I had -2, 3, it would be -2i plus 3j. If I had 2, -3, it'd be 2i minus 3j. So the sign stays on the number. Again, the number in front of the I is the horizontal component, and the number in front of the j is the vertical component. Everything else is exactly the same. When the question gives it to you in IJ format, like this one, you need to make sure that your answer is also in IJ format. So you have two choices here. I can take what's here, convert it into component form. This would be 0. This is a j, so this would be 0, 2. And work it out the way we've already done it. Or, I think even easier, is just use it in terms of a variable. So if I was doing A, U plus V, then I would take U, which is 3I plus J, and I would add it to V, which is 2J. And then simply combine your like terms, and you get your sum. Now, the sketch of this vector would go from 0, 0 to 3, 3. B is U minus V. So now I'm going to do U, which is 3I plus J, minus V, which is just 2J, and I get 3I plus J minus 2J, or 3I minus J. There's my vector. And then I'm going to graph it. This time, I'm going to go to the right 3, down 1. And C is 2u minus 3v. So I'm going to do 2 times u minus 3 times v. And distribute the 2, so I'd get 6i plus 2j, and then distribute the negative 3 minus 6j, and I get 6i minus 4j. There's your vector. And then we would graph it. Right 6. Down 4. Next up is unit vector in the same direction. So if we want to find a unit vector in the same direction, we want the new vector to still have the same change in x and change of, or same direction, so change in x and change in y. But unit means that my magnitude is just going to be 1. So I only want it to be 1 unit, so I want the length to be 1. And the way we find this is by taking the component form of j, or sorry, the component form of v, whichever one we're trying to find, component form in the numerator over the magnitude of that same vector. So this is going to be a comma b, and this is going to be a single number in the bottom, and then we'll split and simplify it. Directions will say find the unit, so the unit is important here. Unit vector in the same direction as the given vector, and then verify that the result has a magnitude of 1. So if your answer is a unit vector, its magnitude should only be 1. So we're going to look at A first. So A gives us 1, negative 3. My numerator is going to stay 1, negative 3. And then my denominator is going to be the magnitude of u, which is the square root of 1 squared plus negative 3 squared. Square root of 1 plus 9, which is square root 10. Now both 1 and negative 3 get the denominator, so I can split this. It would be 1 over root 10 and negative 3 over root 10. And then we rationalize. So I get multiply both by root 10. And I get root 10 over 10 minus 3 root 10 over 10. And then what you may see in multiple choice format is they'll actually pull out the 1/10 on the front here. And it would just be root 10 minus 3 root 10. If it's open-ended, I will take either answer, this one or this one. But you'll see on the homework and the multiple choice that usually they'll pull out that 1/10. Now, the way you confirm that the magnitude of this one is 1 is take your component form, and you can take it actually even before you rationalize it. So 1 over root 10 and negative 3 over root 10, and do square root of a squared plus b squared. So 1 over root 10 squared plus negative 3 over root 10 squared. And this is the square root of 1 over 10 plus 9 over 10, 10 over 10, square root of 1, which is 1. So if you've done it correctly, then whatever answer you go to give at the end, if you have time, check it, find the magnitude, and it should be 1. All right, so now let's look at B. B is also a vector, but this time it's given in IJ format. This is when it might be easier to take it out. So this would just be negative 3, negative 4 in component form. That's going to go in my numerator. Then my denominator is going to be the magnitude of V, which would be the square root of negative 3 squared plus negative 4 squared. Square root of 9 plus 16, square root of 25, which is 5. Remember yesterday we said triples work here. This is 3, this is 4. Magnitude would be 5, and the hypotenuse is never going to be negative, so it's always positive. This goes over 5. This time when I split it, I get negative 3/5, negative 4/5. That is my unit vector in the same direction. To check it, I can do the square root of negative 3/5 squared plus negative 4/5 squared. And I get 9/25 plus 16/25. 25/25, which is the square root of 1, which is 1. So this is the magnitude unit vector, in the same direction as my initial vector. Okay, example 5 says let V be a vector from initial point P, -2, -2 to terminal point 2, 3. Write V in terms of I and J. So it gives you the graph. If you wanted to graph it, you could do -2, that's P, and then 2, 3, this is P1, this is P2. My vector would go in the direction of P2, the terminal point, and it would look like this. And then I want to know my change in X, change in Y. I have two choices. Count it. 1, 2, 3, 4. That's a change in X. 1, 2, 3, 4, 5. That's the change in Y. So it'd be 4, 5. Or use the points here. I'd get 2 minus a -2. 3 minus a -2. Remember, order matters. This becomes plus, and I get 4/5. But it says in terms of I and J, and so I would just do 4I plus 5J. Writing a vector in terms of its magnitude and direction. So now we're going to kind of work backwards. It says let V be a non-zero vector. So you already have the magnitude. If theta is the direction angle measured from the positive x-axis to V, then the vector can be expressed in terms of its magnitude and direction angle as the magnitude of the angle, or the magnitude of the vector, times the cosine of theta, and the magnitude of the vector times the sine of theta. So remember that cosine is our x and sine is our y, so this makes sense. I want to just do the magnitude times the cosine, magnitude times the sine, and this is inputting it in terms of I and j at the end. So this is a way to write component form if given the magnitude and the angle. So I would know what the angle is. Let's say it's 45 degrees. And I would know that this is, 10. And I want to actually find the component form of this vector. I would do 10 times the cosine of 45 and 10 times the sine of 45. You'll also see it in radians. So this says, find the component form of V given its magnitude and the angle it makes with the positive x-axis. And then sketch V. So again, component form would equal magnitude of V times the cosine of theta, comma, magnitude of V times the sine of theta. Or we're going to do magnitude of V times the cosine theta I plus magnitude of V sine theta j in terms of ij. So this would be 2 root 3 times the cosine of 45 degrees, 2 root 3 times the sine of 45 degrees. And hopefully we haven't forgotten our unit circle, 45 degrees. Our coordinate point there is root 2 over 2 and root 2 over 2. So the cosine there is root 2 over 2. And the sine there is also root 2 over 2. So these 2's cancel, and I get root 3 times root 2, which is root 6. These 2's cancel, and I get root 3 times root 2, which is again root 6. So this would be the component form. In ij form, it would be root 6i plus root 6j. Then it said sketch it. So when we sketch this, obviously we have to approximate. Root 6 is in between 4, root 4, and root 9. So that's in between 2 and 3. I can say it's 2.5. So I'm going to go to the right, 2.5, and I'm going to go up, 2.5, and I'm going to draw my vector. And it should be about 45 degrees, which looks accurate. And if it was 2 root 3, that's like 2 times 1.4, or 2.8. If we actually measured this out, we should get about 2.8 as our length. Last thing in this note just says find the component form of the sum of u and v with direction angles theta u and theta v. And it says hint, find the component form separately and then add the vectors. So I've got 2 vectors here. I'm going to first find the component form of u, and then I'm going to find the component form of v, and then at the end I'm going to take and add u plus v. So here's my magnitude. Magnitude times the cosine of theta, which is 0. Magnitude times the sine of theta, which is 0. And at 0, again, hopefully you remember that coordinate point is 1, 0. So the cosine is 1, the sine is 0, and my component form of the first one, which is u, is 5, 0. Which should make sense. If I make 0 degrees and I go out 5, that point should be 5, 0. And v, magnitude is 5 times the cosine of 90. Magnitude of 5 times the sine of 90. 90 degrees is here. Coordinate point is 0, 1. Cosine is 0. Sine is 1. And this time I get 0, 5. Again, should make sense. This is 90 degrees. We're going up 5. That matches. So here's my u. Here's my v. And I want to add them. So I get 5 plus 0, 0 plus 5. And this sum would be 5, 5. If you were to graph those, if you think about what we had, the first one was 5, 0, 1, 2, 3, 4, 5, then 0, 5. Those would be my vectors. If I drew the line parallel off this side, it would look like this. The line parallel off this side, it would look like this. They would cross here, which would be that 5, 5. So everything that we've talked about should be consistent and overlap. The sum, the component form, the magnitude, all that stuff should overlap and make sense. All right, that wraps up the notes for 6.3. Make sure you submit the notes. You can either do just the notes from today or the entire section's worth of notes. Either one's fine. You're going to submit it to the classwork assignment. Then you're going to work on your 6.3 homework with the remaining time. Have a great day, guys.